Hey everybody, welcome back to the channel. I know it's been a minute. I apologize for the delay on the videos. I've just been busy working, so I'm going to show you what I've been working on the past couple of days. It is a library that will contain all of the networking logic and stuff that's going to be used in the app. So I'm going to do a little bit of work today on this. This video is going to be about 20 to 30 minutes kind of describing what I've done thus far and what you can expect in the near future. So the first thing is I am breaking all of the module components down. Now, a couple things I want to point out is I'm going to stop using pre-compiled headers in all of my projects, and I'll kind of explain why in a moment. But before I do that, I will show you a really cool thing about modules that I just learned, and I'm not sure if most other people knew it, and it is the simplest thing ever, and I really had no idea what until now. So the past few months, I've been working on another project, freelancing for a third-party company, and they're using C++20 with modules. Now, the cool thing is, in Visual Studio, C++23 is basically almost complete. So I moved all of this library over to C++23, and you have this cool import STD. Now, I should have read the docs, and I didn't, but I was trying to use things like fread, just a, here, I'll show you. So we do std.compat. So this, for me, was the game changer for modules, because this compat thing here, I don't know why I didn't read the docs, why I didn't look at the standard stuff, but if I were to go over to fread, why is it not popping up? Oh, it's got to be a, yeah, there it goes. So I could do like sharp buffer, let's do a kilobyte, we'll read the buffer, 1024, and we'll pass in a file. So let's see, we have our buffer. I think this is the number of elements, the size for each element, and then the file. I don't know because I can't see it yet. I have to look that up. So there's fread here, which is the standard for C, and you still don't get this underscore S thing. So this really infuriated me. So those of you who are familiar with C programming on Windows, there's this oh, it's not that, it's no lock. That's what I was trying to do. So you have this no lock thing. The way the Windows implementation works for fread is it actually has a lock. So it locks access to the read and write part of the buffer. So if you have a single threaded application, you're basically paying a price for no reason. And so there's this no lock functionality that's kind of built in to the Visual Studio C stuff. And you can't do this with this. And because we were using pre-compiled headers before, I would have to go back and I would have to include that. But then there's also all these weird macro things that I was worried that weren't going to come in without doing the pre-compiled header thing. Well, it turns out you don't have to do that anymore. Or at least maybe never, and I was just unaware of it. But if I were to port CSTD input output, okay, you notice that it brings in the entire header here. I think I can do this too. So let's look at the difference. So there's fread underscore s, which is the safe version. I don't know what the hell that other parameter is, but so now we have underscore s. See, and the only other thing now is, what if I want to do C current? Oh, look at that! All of my standard IO stuff from C is brought in. All the macros are brought in. And it's because you could just import a damn header file. I didn't know that. So this is my fault that the past couple of videos we've been using a precompiled header, and it's actually recommended not to do that anymore, just to do your import statement. So only import what you need. And if it's in the standard library, starting with C++ 23, you shouldn't import like string and all that kind of stuff. You should actually just import STD, which is a basically the entire standard library. Now, the main argument against this in the beginning was, well, it's got to be slow to bring in the entire standard library. And then I've also heard that bringing in the entire standard library through the module system is actually faster than including IOStream. So, what did Josh do? I went on a hike and I actually looked at the module code and I found out exactly what it's doing. And I can tell you right now that importing STD is like 10 times faster than including IOStream. So you can get the entire standard library in a single import. So all my projects now are C++ 23. And this thing is saving my life and completely getting rid of the need to do or use precompiled headers. So I'm over here messing up my library now. So let me get rid of all this stuff and I'll kind of show you the library thing that I've been working on. So the first thing we'll go over is we'll go over the main module system. Now again, all this eventually will be moved into what you would call a primary, like a single library, if you will, like a single code base with all the files. I just have them split up into different projects here just to kind of make things a little more organized. So I'll do the work here and then I'll just take the time to copy all the source files over, and then you can compile into a static library or just whatever you want to do. But I won't be providing any actual libraries to this stuff. It'll just be the actual files themselves. But again, I will walk through videos, especially in Visual Studio, maybe with code blocks using GCC or something, how to actually compile this for people who don't like command line tools and stuff. So we'll go over the jp3.cpp. This is just a library that I'm making, and it literally just imports all the individual components. That's all this does. There will also be an entry point module in here, and I anyway am going to use it, but it's going to basically allow me to get rid of the use of main and WinMain and all that kind of stuff. So depending on the subsystem, you have the same entry point, and it just sets everything up for you automatically. So let's see. So that is just importing and then re-exporting the core library, the math library, and the networking library. And again, I will be making a GUI library and all that kind of stuff in the near future. It's just one thing at a time. And these three things are not even complete yet. This is just some of the utilities that I've had time to work on in like the past 2 days. And that's, I mean, it's Easter, so it's been very little time that I've had to actually work on this stuff. So the first thing that I'll go over is the core. And what the core does is it brings in these individual components. So the first thing you realize is unique resource. I'll go over this first. And what unique resource is, it's basically that safe socket that we created in the beginning, and then I eventually went over to a resource or whatever. So this is a unique resource, and it does everything that the old unit does, except I added a couple of tags. I fixed a bug that was in the move assignment operator, and the bug basically was it had a copy and swap, and if you pass in the same thing, and this was actually private message to me. They say, hey, you have a bug here. You don't have to tell anybody. Just say that you spotted it. No. This was pointed out by a member who viewed the video, and thanks to him, he said reference to the standard library, see how they're doing it, and I'm like, oh, that makes sense. So if this is not the address of RSS, then we'll reset, because otherwise it's the same object. You're referring to the same thing, and you're just resetting something and exchanging invalid values. And basically what you're doing, if this were a socket, you're just closing the socket and then returning what you think is a valid socket, but it's not. So that has been fixed and addressed with this library. I would also like to point out that everything that's already written has been tested except for the networking stuff. So I do have a separate library with unit tests. So I'm writing each of these components separately into like their own projects, add them into this project, and then this project eventually will be moved to a third project, which is the master. So this basically does everything that you needed to do, except I have a strict enforcement policy, is that the deleter must be no except. And this is because you're not supposed to throw exceptions in destructors. And this allows me to use whatever deleter. And if there's an error inside of the deleter, I'm sorry, but you can't be throwing exceptions inside of destructors anyway. just log the error and go on about your day. I don't think there's any useful implementation stuff in here except for I added explicit operator resource. This allows you to basically, if I have a socket, I can, here, instead of doing this, I'll just show you. So I'll go ahead and struct the leader. Can't type today, and then void operator dot int I. We'll actually go over two things first. The first thing is to show that the no accept does not work. So now I will create a unique resource, call it R, and the resource type is that with 0, and then my deleter. And now I have this, oh, what the hell was it? So I can't pass this in. So if I have a void bar that takes an int I, okay, oh, look at this, the static assert failed. Static assertion failed, the leader must be no accept. So now if I were to just compile this real quick, so let's just build it, and what you'll see is that you actually get a good error message. So static assert failed, unique resource deleter must be no accept. So now I mark this as no accept. If I could type, I think the microphone's in the way. Let me adjust that real quick. And now if we go and rebuild, you'll see that there's no build errors. So everything's fine now. So it literally makes the deleter's operator overloader for the function call. The functor must be no accept. There's just no way around that. Let's see. Oh, let's go over implicit this. So if I pass in R to bar, right, you notice that it doesn't work. But if I type int I equals R, you notice that that doesn't work either. But I can static cast to int, and it's not an issue. And now I can pass an I. So this right here is kind of cool. Everything's also const expr. So if I were to set this to 5, const expr int I, and now notice I is 5. So you have this really cool unique resource class. It's going to be really useful for things like sockets and window handles. So that's done. And I'll show you going over what we'll actually do real quick. I'll go ahead and show you. So I want to create one for a socket. So I'm just going to import WinSock real quick, and I'll get rid of all this. Import WinSock2. Struct socket deleter. Void operator socket no accept. We can also make it const, and it can't be const expr because the function we're going to call is not const expr. We can call standard ignore, set that equal to close socket, and pass in the socket. Done. There's my deleter. Now I could say using socket handle is going to equal unique resource socket, give it my invalid socket, and pass in my socket deleter. Done. Now I have a socket handle fully compatible. It safely releases. That's it. And this unique resource, I should point out, should not be replaced with unique pointer or shared pointer if those standard options are available. This is useful for things like sockets and window handles where you have separate functionality, or even if the invalid, like if the invalid state is not null pointer. So like with a handle window, the invalid state is null pointer. So that would be a good chance or a good opportunity to use a unique pointer. But if you can't use unique pointer, or maybe you want to have a familiar interface in your API like I do, I will be using specifically unique resource like this. So my handle window and my socket, all that will be a unique resource. But if you have a third-party option, like if you need to create a unique resource type of a file, like I literally mean the C file, Do not use unique resource. Use unique pointer with a custom deleter, and it's written exactly in the same manner as this. So we'll go ahead and get rid of all this stuff now. That was just me kind of showing you. So unique resource is cool. It's a nice little RAI type that kind of just wraps anything, and it will do exactly what you tell it to do. So it takes a little bit of thinking, but it's not that hard. It takes a resource, and then a resource's invalid value, and then a deleter, which I just showed you exactly how to do it. You can also dequal type a lambda and use that lambda as the deleter. I don't recommend that. Create a name type, and as long as you're using modules, you don't have to export it, and you don't have to worry about the name leaking, so you're good. All right, so now we'll go over initializable. This is a very basic type. What this type is, basically, is it is a trait that's used to detail something as initializable. So it just stores a bool. This is literally the size of this object is 1 byte. And so you can just tag this onto any other type. And I'm using it actually in the networking library. If you come over here to network, you'll notice that the network is an initializable object. So instead of throwing exceptions, I'm going to let the exception handling be passed off to the user because this may not need to throw an exception. So I just decided, hey, well, no accept everything. I'll go ahead and inline these since I'm here. And then I just have this as network initialize function. Notice this is not exported. The network here is not exported, but this function is. And then so at the beginning of your application, let's say you would have like int main. The first thing you call if not is network initialize. Then you can, log an error. And if it's necessary, you just exit the program. That's the easiest way to do that. And then it's static storage, automatically cleans up. Problem solved. All right, so we'll move on to the next thing in the library. So initializable, basically, it just has an initialization state. You can check if it's initialized, and you can set it inside of the constructor. Instead of throwing an exception, the default value is false, that it's not initialized in your constructor. If initialization succeeds, you set the initialization state to true. Later, you can get whether or not it's initialized outside, and everything's publicly passed down so you can get is initialized. And the set initialization state is protected, so no outside source can actually set the initialization state. All right, now we'll go over Indian. One of the biggest problems we had, and I actually did this in a separate project earlier, and this should actually be exported. We have the standard Indian type, which is native, big, and little. But the problem with the native one is the values aren't guaranteed to be consistent. So for instance, if I need to send over the network, whether or not, let's say I'm on Windows and you're on Linux, and I send you this byte to differentiate between our network Indianness, right? Or between our native machine Indianness. So I have a little Indian machine. Let's say you have a big Indian machine. So I send you STD native, and then you on the other end, on the Linux end, are going to check whether the native is little or big. The problem is this is compiler and implementation defined. The values are not consistent. So they don't always equal what they equal on MSNVC or MSVC or any of the GCC compilers, libs, C++, and all that kind of stuff. So I just wrote this simple Indian class that has the same types, and it has the same values anyway, and it uses the standard native Indianness built in, and it allows me to essentially set Indian to the byte type, so you don't have to worry about Indianness when sending this. So you just send the Indianness, the native Indianness, in the network. Someone else can use this exact type and differentiate between whether or not the peer connected endpoint is using a little or a big Indian machine. Problem solved. All right, so that's the logic behind this anyway, and I had to do this in a project a couple months ago. So I just said, oh, well, I've already done that, so let me just move this over. And the network equals big here. Everyone knows network Indianness is big Indian, but it's just there to keep things specific. Entry point, we're ignoring this. This is what I was using to test stuff earlier. I don't know why I moved that over. All right, so now we have event. Let's do Eventargs before I do event. All right, so Eventargs is another simple type that will be used within events if the arguments are designated for objects. So if I have a class player and then I have an event, I need to be able to pass in some sort of argument to that event, right? So I will create my own Eventargs. Let's say player moved or player shot Eventargs. So this is something like if you're making a game and the player shot, right? Or player damage. I'll just keep it like this. I'm not worried too much about monetization. So if I can pass in my player like this, so I can call class player. Now that's good. So now I have my player shot Eventargs, which is just an Eventargs of player. You simply call using Eventargs. This is like the standard way of doing it, unless you want to manually forward all the arguments. I'll show you how to do that too in a second. And then I just have the like int damage, right? Oh my god, why can I not spell? There we go. So now we have damage. I'm going to default it to 0. Even though it's a struct, everything just defaults perfectly fine. Now, here, so I have this damage variable here. Here's what's cool about this. So now I have an event args. So if I have player shot event args, shot, let's wrap this inside of a function. So let's say this is player shot. So this is our actual function for when the player gets shot through whatever physics system or whatever that we have set up. Notice that I can't actually just create a player shot event args. I have to actually pass in the player. So as this event args happens, there's this object within here called the caller. And this is whatever this is passed in. So in this case, it's this instance of the player. So I have the standard damage, but then I also have caller. Now, you'll notice caller doesn't have anything on it, and it's this weird event args caller type. Well, what is that? Well, it's essentially just a pointer that is contained, and it allows you not to copy, move, or set the pointer. It just keeps the caller intact, basically, and you can't mess it up. I mean, you can still reinterpret cast and bit cast and all that kind of stuff. I'm not talking about that. You have to intentionally mess it up. So this prevents a user from messing with things. It's not a reference on purpose to keep in consistency with the calling convention of this library. So if you have a caller, right, you can't use the dot operator, but you can use the arrow operator. And because it's a pointer, right, it just allows you to start accessing the stuff on the caller. So it acts exactly like a pointer, just one you cannot set. You can't change it, you can't set it, you can't do anything. And I actually may just make this const. And now you definitely can't change it. Cool. So now we have this caller. Uh-oh. But then you run into this problem where you can't actually start calling functions on here. So the easiest way around that is to just avoid copy and move. And once it's constructed, it has to stay constructed. Okay. And so now I have access to, it should be player shot like this. Now if I make this const, do I have access still? I do. Cool. Okay, so yeah, so I'm going to keep that constant. All right, so, and then if you need it to be const, we can pass in const player like this. And now you'll notice that it can't call that function, but I can const it here and everything's fine. So that's event args. It's useful for you to be able to pass arguments around during events, more specifically events tied to a caller or an object. Now we have the event. This is the simplest class so far. It just has like 3 methods, I believe. I think it has subscribe, unsubscribe, fire, and then remove all subscribers. So this one, pretty obvious. It just clears all the callbacks. Unsubscribe takes an ID and it just unsubscribes you from that event chain. Subscribe, you cannot pass in null pointer like a standard C style function. Normally can be passed in the standard function. This does not allow you to pass that in. It's just a security thing to help you not use, or to help you use the API correctly. And then we have this subscribe function, which takes in any kind of func that can be passed in to create a callback. And what we do is during subscription, we first check to see if there is a null callback, a callback that's been unsubscribed to, and all that does is set the callback to null pointer. If there's one that's null, we simply assign it and return the distance between the beginning of the callbacks chain and the current iterator. Otherwise, we push back a callback and we return the size -1. Problem solved. So you subscribe, unsubscribe, fire, takes in the args, perfectly forwards them, done. All right, so that's the simplest one. I'll show you real quick how to do this. So I'll create a void foo. Now, if I have an event that's supposed to take in an integer as a parameter, I'll just call this e. Now I can subscribe to E, and this is going to return an ID, and I can pass in a lambda as long as the lambda returns an int. It must return void, and I can also mark it like no accept and things like that, but I don't even worry about that, not for lambdas. All right, and now in here I can just I'm just not going to do anything. This is a demonstration of how to use the API. I can unsubscribe the ID, done. I can remove all subscribers. But here I can do e.fire and I can pass in number 5. And now what that will do is every subscriber that's subscribed, their functions will be called on the same thread sequentially in order. So there's no thread safety here. So, oh, well, I'm using a system that requires events, but it needs to be thread safe. How do I make this thread safe? And it's really kind of simple. So all we do is I'm just going to create a struct, call this event template type name ... args. So you just copy it exactly like me. So I'll just call this MT event for multi-threaded event. And I'll do public event, pass in my args ... and then create a standard mutex like this and default construct it. Now I have an MT event. All I do is change that to an MT event. Now I have this. Now during anytime that we're actually physically calling something, right, there's no need to actually contain the actual lock. I mean, you can always do things by reference. There's no need to actually capture the mutex here. So what we would do, right? Oh, well, now we're subscribing. So we would, in essence, this would be inside of a function. You would create a standard scope lock, call it lock, and pass in e.mutex. Done. Now, we just have to copy this during all of our calls here. But it makes this explicit. So instead of providing a mutex and creating extra memory or anything like that, it is literally this easy to make this event system thread safe. Okay, so there's no need to do anything extra. All we have to do is create this simple struct here, and you can specify your own lock, your own mechanisms, your own functions, all that kind of stuff. So I don't worry about multi-threading. Multi-threading is a per use. So if you need multi-threading, it's as easy as that to create a thread safe or a multi-threaded abled event system. Like it is that easy. So now we have, I think that's everything in core that I've made so far. All right, so now let's go off to our math library. Shapes is nothing right now. I'm just working on some geometric shapes. All right, the random one's the one I'm most excited about. All this does basically is it just has a bunch of neat functions to get some random stuff, the next element out of a container, the next bool, the next byte, the next floating point number, the next int. Everything has defaults, and then you can specify your own like floating point type. So I can do double, and then there's an edge case here where the standard random distributions, so like the uniform int distribution, doesn't work well with int8t, right? Well, if I have a single byte, but I need to be able to get it as an integer, call next int with that type, no problem. I simply say, hey, if the t is the size of 1 byte, then I will cast it to an int, and then I will return that 1 byte object to you from the distribution, and everything's fine. So I actually handle those edge cases that the standard says you're not supposed to do. I handle them even though it says you're not supposed to do it. I don't care. I'm handling it because it's useful for me. Let's see. I think that's it. I don't think there's anything. Oh, yeah. The next byte, so it just returns a random standard byte. And by default, all of these return like some good default. So it's between min and max for all or any type that you give me. It's between min and max. And the bool, the default chance for true is 0.5. And that's it. And then the next element is any container that you can call standard size on and has the array subscript operator. So this would be C style arrays, standard array, standard vector, and a couple other cool container types. Okay, and all it does literally is it just returns a random element. There is no, again, that's all this does. It only returns a random element. So there's no way to specifically state, hey, I want to return elements in, from this range to this range. It doesn't do that. If you need that, you need more specific. You need a more specific implementation of random. Which, by the way, this isn't final, so you can inherit from this and just start making your own functions. So if you want to use this, but you need customization, just inherit from random engine. And then my using random is just random engine with the default engine. That's it. Okay, and let's see here. Scalar is a concept. Basically, if it's an arithmetic value, problem solved, done. And the reason we have that is because we have positions up to 4 dimensions. So eventually this math library is going to contain positions. It already has positions and points. It's going to contain things like sizes, dimensional rectangles, which is where the shapes come in. All this is built on that scalar concept. So vectors, quaternions, matrices, anything that you need to make advanced, like a rasterizer engine or even a video game, or even physics simulations, just whatever you need. Eventually, this library, this math library, will have the basic fundamental types for you to do this. It's not going to have any monetary stuff. I actually thought about adding like a money class, but that's too that's too generic. I mean, how many C++ programs actually deal with money? And when they do, they probably are major businesses that already have their stuff in order. So, and I actually want to make. I currently am working on a game engine, so it would be really cool to be able to just port all of this stuff over and be able to use the library under a different name. I'm not going to ruin anything yet, but this exact library is written in 2 places with a different namespace, and it's the name of the game engine. But I will not go over any of that stuff at the moment because nothing's guaranteed. All right, so that's the math library. So we got math, we got core, and then networking is stuff that I'm going to be working on. You already saw network. It's just a hidden class that you can check if it's initialized or not. A network result. So this is going to be a result that's returned from certain functions. So there's going to be certain things that are inherited from network result, and a network result will just be the base. So like if I may have like a connection result, which will have a socket, or it will have other implementation defined things built into them. But this is the basic thing here is I just return a network result. And again, there's going to be a hierarchy to this. Like I already have one for IP endpoint result, which literally just takes an IP endpoint or an error. And then I just store the endpoint. You can get it like that. Oh, again, this is just me testing the network object, which I can't do anymore. I just changed that live on this video. You really start to see it with the socket, right? So the socket, we have socket type. The ones currently supported are stream and datagram. And then we have where is it at? The address family. We support inet and inet6. That's about it. Now again, these lower level constructs here are going to be used for the actual socket class, and this is going to basically allow you to create any kind of socket that you want later on in the future. So socket is basically just a wrapper around the native socket functions. along with the socket handle thing that you see here. So if I come down to socket handle, you'll notice that this is a unique resource. Well, I don't really like this. So we're actually going to rewrite this, right? And we're going to do it now using the core library using unique resource. So I can import jp3.core unique resource. All right, so now that's done. I'm now going to export. I don't want to export the entire namespace because I'm going to have that hidden deleter. Struct socket deleter inline void operator dot dot socket const no accept, and then standard ignore equals close socket, give it the socket. Okay, cool. And now export using socket handle. It's going to be a unique resource for socket, invalid socket, and the socket deleter. And for some reason this is not working. Let's go ahead and compile this, see if there's any like bugs or anything. Is open is not a member of unique resource. Oh. Switch it to is valid, I guess. Could not open module socket. Oh, is there like a dependency issue or something? Oh, yeah, I need to recompile this. So recompile this. This is up to date, and then rebuild this. And I have my reference there. Is open is not a member. One succeeded. Okay, cool. It's just having a hard time importing the symbols, I guess. Yeah. I also need to rework all this, make these individual components too, because the partitions I think are really useful for like sub-libraries. So like I did that in the math one, right? So like I have this position here, but I only want to import position, and all of these could be in one file, but I found it easier to put these in separate files, and then I can make these a partition of the position file, and then I just export import all of them and done. And now when I come back to my math, I just export import position instead of all the individual components. And it actually makes more sense, right? Because if I only want to use the position part of the math library, I can do that. I don't have to import the entire math library. So I kind of like this. So I'll be structuring everything like this from now on. So this is what I've done, and it's been, I don't know, 6 hours maybe, with a little bit of thought in the past couple weeks. So once the networking part gets done, probably in the next 2-3 weeks, I will move the existing code from, oh my God, what was the name of the app? I done forgot. This is the problem not working on something for 6 months. Remote desk. I will move everything from remote desk. I will basically get rid of the precompiled headers and move over to the importing the actual header that I want. And again, we can make one header file that already has everything set up. The same thing, stdafx, and just import it. Now you don't need a CPP file. It's no longer a precompiled header. Everything just works. So I will move everything, get rid of the precompiled header. I will move over this library as a static library to that project once the networking part is done. Because the core, I think, is about as good as it's going to get. And then I'm not going to do any GUI or anything like that in this project yet, but I will be writing the GUI stuff in Remote Desk, keeping everything that I've already written and kind of modularizing that a little better. So I will try, and the main reason I'm making this stuff right here super generic, things that I will be using in a lot of my projects are going to be in this library. So if you have very similar needs, which I've noticed I have needed, I have, like, the reason these things are here is because I use them religiously. Like the ability to have an event system, just plug in the event and it works with all the other components built into this library. To me is really useful. It's, by the way, it's actually fast. So I was actually surprised. I did some speed comparisons, and I don't even reserve memory as on the default constructor. I have a constructor that allows you to reserve if you know for a fact that you're about to bind, let's say, like 6 handlers. I can reserve enough space for 6, and it does 1 allocation, then it will just start binding. So that is an option. But then I also have, when I was doing the tests, I actually used a video game simulation that I've written in the past, and it's just a very simple 2D game. And I had a very basic C style event system in it, and I stripped that out and used that event system. I actually saw a speed up. I'm not kidding. I went from C style functions to that, and I saw like a like a 2 millisecond per frame speed up. And I know that to most people that doesn't sound like a lot, but I was now able to add more entities to the game, and I thought, wow, this is neat. I mean, it was already getting 120 FPS was my limit cap. And so I was constantly hitting that already as it is. But then I had a 2 millisecond per frame speed up. And I'm like, literally from the event system? Because everything was in the event system. If an AI entity hit a wall, that would be popped out to the event system. And then there was all these functions that were trickling down. And this allowed an event to be tied to individual entities. So I actually had an event component. And the event component, it just had an event, and so it was a template. I specified what kind of event it was, and then now I had an event on an entity that anybody could hook into if they had that entity ID, and it was really neat. Um, and again, a 2 millisecond per frame speed up on average was amazing. So it was like, this system isn't. I didn't even optimize this. That's what's crazy. Like, I did nothing to physically optimize this away. And by the way, I mean that this exact code was exactly what I wrote. And it was so much faster than using C style functions. It was crazy. And it uses standard function, by the way. And I always thought that function allocated. And again, the it could just be the MSVC compiler, but standard function is designed to work with function pointers. So it has like a stack buffer. If it can fit in the size of a pointer, everything is fine. Well, it turns out that if you use a lambda and you capture something by reference, a reference essentially is a pointer. And as long as you're capturing one thing, that function is guaranteed to be on the stack. No allocation required. I thought that was nuts. And so when I started looking into that, I was like, okay, so all my lambdas, oh, I see here I need to capture 2 things. So I just made a struct that took both of those things by reference and then passed that one struct by or captured it by reference. And it was here, I'll show you exactly what I did. So I'll show you which one's heap allocated and which one's stack allocated, at least for MSVC. So void foo, and then I will have a struct A, which will have an int I, and a struct B, which will have like an int I, right? So I need to, let's say if I have an event that will take argument as an int, and I basically need to store it in both of these. So I'll just call it E. Now, if I have, I'm going to subscribe int num e.fire 5. So now I need to take A and B, and I need to upgrade all of them. So I'll capture by reference like this. And then I'll do a dot I plus equals num, and then b dot I plus equals num, right? Now this lambda, when put inside a standard function, allocates memory. Now why? Well, it's because standard function is designed, at least on MSVC, if it's the size of a pointer, don't allocate. Don't allocate memory. Use that available space and just copy the bits over, right? So this, even though I'm capturing one reference, it captures both of these by reference. So what each reference actually is just basically a pointer in assembly. So this is actually the size of 2 pointers. And I'm like, okay, well, why is this doing this? So this, right, I couldn't figure out in the beginning, because originally there was a slow down, and I thought, well, that's weird. I mean, I would at least expect the same speed, but a 10 millisecond slowdown, the game was actually lagging. And then what I did is I realized that this is having to allocate every time I call subscribe. Okay? And you're subscribing a lot, and I'm subscribing in the middle of frames sometimes, right? So I'm like, okay, well, now that I know, I went digging into the code and realized, okay, well, it turns out standard function on MSVC, if it can stack allocate it via the size of a pointer, everything will be fine. Well, it turned out that all I needed to actually do was create a struct. I'm going to create a struct C here. Take an A reference A, B reference B, okay? And now if I create this struct C, I pass in A and B like that, right? Now I just have this reference to A and B. Now all I need to do is capture a reference of C. Ah, well, what is this? C.A, C.B. Oh, wow, look at that. And now this is literally the size of that, no allocation. It was that easy. And actually, what's even crazier is I was just doing this. So, like, I was just doing it in line. So I was just like, struct with no name, and I'll just call it C, and I'll say A ref A, B ref B, like this, and C is going to be A, B. Oh, wow, look at that. Now I have this anonymous struct. It doesn't even have a name. It's being used only inside of a function. And it looks weird. It's weird syntax. I get it. But this is a one-liner, and I avoid an allocation. I thought that was the coolest thing ever. So the ability to control memory like that in C++ is just amazing to me, which is why I love this language. And then once I did that, going from the old one, just capturing by reference, to capturing like an unnamed struct by reference, and whenever I needed it, guess what the speed up was? It went from 5 millisecond loss each frame on average to a 2 millisecond gain on average per frame. Using standard function, using the event system like this. I was actually amazed, because I always thought standard function was slow. Turns out it's not slow at all. If you use it correctly, you can get huge benefits from using standard functions, because as long as you're avoiding standard bind, which is almost guaranteed to allocate, you can avoid most memory allocations, at least on MSVC. I hope it's the same on all the other compilers. I mean, I'd imagine like GCC and libc++ probably have similar non-allocating versions of standard function. And again, if you need to allocate, you just need to allocate. Like, if there's no way around it, then there's no way around it. But this in particular was fine. Now, if you use standard bind, guaranteed you're getting an allocation. There's just no way around it. But I actually thought that this was really neat. And again, in my simple 2D game, I only have one thread dedicated to like the logic. So all of that was where the event system and the ECS system sat, and then all the rendering happened on a separate thread. And don't even ask me how I sync those two together. I don't even understand the threading mechanism behind it. I just screwed around with a bunch of threading stuff until I got the best performance, and then I said that's what I'm sticking with, and I just went with it. And that's probably going to be in my game engine too. I understand how it works. I just don't understand why it works. Like I just cannot wrap my brain around, because it's not even using it's using a spin lock and an atomic flag. And I mean, so a spin lock essentially is an atomic flag. I mean, it's using two atomic flags. One is a spin lock, and one is used to set. It's actually an array of atomic flags. It's used to set whether a specific render target is ready or not. It was, it's weird. I don't understand why that's faster than just using the mutex or just a standard spin lock, but it was faster using the atomic flag with the spin lock than just using the spin lock. I don't know, but anyway. And again, that's also on my machine, but I gave the game to a couple friends. It was faster on theirs too. So I don't really know. I just have to trust. I have to trust not me, and trust the multi-threading community because I don't really know half of what I'm doing when it comes to advanced like atomics and stuff. I have no freaking idea. I'm not an expert. So, but the event thing surprised shit out of me. And in the Eventargs I just made because I had this collar thing and I accidentally reset the collar. So I said, what if we could map everything into Eventargs and then have an Eventargs color object that no one can create, so there's no way to copy it directly, and it can protect the individual pointer or the pointer to the collar. And I said, no, that's cool. So there, we have this cool little type here that makes things real easy for us. So yeah, this is a weird update. For the actual application remote desk, I know that this is weird that this is going on to that chain of videos, but the networking videos I'm going to kind of stop for now altogether. And once this networking API is actually ready to go, I will just move that over to remote desk, and then everything else just kind of fall into place. But I also want to strip the precompiled headers out because you really shouldn't use them. You should use imports. And I'm an idiot because I didn't realize you could import actual headers, and it would. I knew you could import headers, but I was always, or at least I was under the impression, because I don't think I was ever told, I was under the impression that if you imported a header, what happened is it stripped the macros out. So it made DirectX Win32 stuff like just hell to work with. Well, it turned out it's not true. Like if you import them, it's fine. I don't know if it was a bug, but I for some reason remember it not working, and I said, okay, precompiled headers, here we go. And that's why you're using the global module fragment, using include. But if you import it locally, it works. So you just create a standard of AFX like I did here for WinSock stuff, and then you see me like importing it here, and all the definitions and stuff. So like if I were to do like WinSock version, look, it's there. And there's no precompiled header in this. Like, there's no trick. And you can see, it compiles. It's like, what? So, yeah, I don't know. That's pretty much it. So, I will release another video within the next couple of weeks and show you an update to this. And hopefully that update will actually be me continuing to work on the remote desk app. I'm sorry. I know it's been a year. This program should have taken me probably not even 6 months to do, releasing a video every couple weeks. But I'm a busy man. I don't know what else to say. I'm always busy. I'm always working. And I'm taking the stuff that I'm applying in real life. And as I'm looking through other people's code, and realizing that some of them code similar to me, and then I'm like, oh, this is ugly. I need to change the way I code. And then I see another guy's code, and I'm like, oh, that code's good. So I'm going to go with that code. So that's kind of where I'm at in life right now, is kind of, as I'm freelancing, I'm kind of learning, hey, I should actually be doing stuff like this. And so that's what I'm doing. And C++ is a beautiful language if you use it correctly. So that's it. I'll talk to you guys later. Y'all have a good day. Peace.